Okay, in this video, I will explain about the multiplication rule in probability. Okay, so in the previous video, you have learned about the addition rule. Okay, now let's continue with the multiplication rule. Okay, when two events occur successively, calculating the probability of event A and B occurring depends on whether the two events are statistically independent. Okay, now under this multiplication rule, we are now calculating the value of probability of event A and B. So event A intersect with B. So the word and here is for the notation of intersection. So now we need to calculate probability of A intersect B. Okay, so we need to use the multiplication rule. Okay, so for a multiplication rule, it is divided into independent events and also dependent event or non-independent event. So for independent event, the occurrence of one event is not affected by the result of the other event. Okay, for example, a coin is tossed twice. Okay, so a coin is tossed 2 times. The probability of getting head in the first event is 1/2. Okay, and we know that when we do experiment of tossing a coin, the possible outcomes is either head or tail. So, to get the head in the first event, the probability is 1/2. So 1/2. Okay, for the second toss, the probability of getting head is also 1/2, no matter what outcome in the first trial, because this is an example of independent event. Okay, the occurrence of one event is not affected by the result of the previous event. Okay, for this example just now, we toss a coin twice. Okay, so for the first time, okay, let's say we get the head. Okay, H. So the probability of getting the H in the first event is 1/2. And then for the second time, okay, we toss the coin for the second time. Let's say we get another H. So the probability of getting H for the second toss is also 1/2, because the occurrence of the second event, the occurrence of the second toss is not depend on the occurrence of the previous toss. All right. So this is an independent event. So for independent event, the probability that event A and B will occur is the product of separate probabilities. This means probability of A intersect with B is equals to probability of A multiplied with probability of B. Okay, let's try this example, example 11. If a couple wants to have 2 children, what is the probability of getting a boy and a girl? Okay, now this is the question. We need to find the value of probability of getting a boy, okay, and so intersect with G. Okay, B is for an event of getting a boy, G is for an event of getting a girl. So now we need to find probability of B intersect G, probability of boy, N, this is for N and girl. Okay, so now for this case, we need to use multiplication rule. To use multiplication rule, you need to identify whether that event is independent or not. So now for this experiment, this couple wants to have 2 children. Let's just think in a logical way. Let's say for the first child, the couple got a boy. Okay, so the probability of getting a boy for the first child is 1/2, because the possible outcomes are either boy or girl. So the probability of getting a boy is 1/2, 1/2. Okay, now for the second child, okay, let's say the couple wants a girl. So the probability of getting a girl for the second child is also 1/2, no matter what is the outcome of the first trial. Okay, Sebab sekarang ini untuk event yang kedua, it is not depend on the outcome of the first trial. Okay, so the probability of getting a girl for the second trial is also 1/2. Okay, walaupun let's say the first trial the couple got a girl. Okay, contoh the first trial dia dapat girl. Okay, for the first trial the probability of getting a girl is of course 1/2. For the second trial, let's say this couple they want to get also a girl. Okay, so the probability of the second trial, the probability of getting a girl for the second trial is also 1/2. Okay, sebab dia tak kisah the first trial tu dapat apa resultnya, dia tak akan mempengaruhi result for the second trial. So this is independent event. I hope you can understand the concept of independent event here. So now back to the question. We need to calculate the probability of B intersect with G, and because this is independent event, so the formula is just probability of B multiplied with probability of G. So probability of B is the probability of getting a boy. The probability is 1/2. Multiply with probability of G is probability of getting a girl. The probability is also 1/2. Okay, so 1/2 times 1/2 is 1/4. So this is the probability of getting a boy and a girl. Okay, next, let's continue with a non-independent event. Okay, so for a non-independent event, the occurrence of one event is affected by the occurrence of previous event. Okay, this is normally happens in sampling without replacement. For example, there are 2 blue and 3 red marbles in a bag. Okay, and we know that from this experiment, the chances of getting a blue marble is 2/5. 2 over total 5 marbles. Okay, let's say after we took that one blue marble out. Okay, we took one of this marble out from this bag. Okay, and now we want to take a red marble. Okay, now the chances change. Okay, because this is sampling without replacement. So when we took one blue marble out from the bag, so what is left in the bag is only 4 marbles. Okay, so let's say the second trial we want to get a red marble. So the chances or the probability of getting a red marble for the second trial, provided that one blue marble has been taken out, is only 3/4. This is because we are removing the marbles from the bag. So for the second trial, now the total marble in the bag is reduced to 4 marbles only. So for the second trial, to take a red marble, the probability is 3/4. 3/4. Let's say I give you another situation. Okay, I have these 2 blue marbles and 3 red marbles. So for the first trial, I took one blue marble out from the bag. Okay, so the probability of getting a blue marble is of course 2/5 for the first trial. Okay, for the second trial now, okay, since the first marble already taken out from the bag, so we only left with only 4 marbles. Okay, only 4 marbles left in the bag. Okay, so now the second trial, I also want a blue marble. So the probability of getting a blue marble for the second trial is only 1/4. Okay, because we only left with one blue marble and the total marbles in the bag already reduced by 4. So for the second trial, the probability of getting a blue marble is 1/4. Okay, now the probability is reduced lah sebab bilangan dalam bag itu pun dah berkurang. Okay, so this is an example of non-independent event. The next event depends on what happened in the previous event. So that is why it is called as dependent event or non-independent event. Okay, when two events A and B are non-independent events, the probability of A and B occurring is probability of A multiplied with probability of B given A. Okay, so this is the formula to calculate the probability of A and B for non-independent event. Okay, this one right here, this one here is the probability of B occurring given that event A has occurred. Okay, we call this as probability of B given A. Okay, probability of B occurring given that A has occurred. Okay, or the second formula to find the probability of A and B for non-independent event is probability of B multiplied with probability of A given B. Probability of A given B here is the probability of A occurring given that event B has occurred. Okay, so these two things here are the conditional probability. Okay, kebarangkalian yang bersyarat, yang mana sesuatu event telah berlaku sebelum event tersebut berlaku. Okay, so this is known as conditional probability. Okay, so the next slide, I will explain on conditional probability. Conditional probability refers to the chances that some outcome occurs given that another event has also occurred. Okay. It is stated as the probability of A given that event B has occurred. Okay, and it is written as probability of A stroke slash B. So this is probability of A given that B has occurred. Okay, to find the value of this conditional probability A given B, the formula is probability of A intersect with B, okay, probability of A and B divided by probability of B. Okay, and the other way around, if let's say we want to find the value of probability of B given that event A has occurred. So this is written as probability of B slash A here. Okay, so the formula is probability of A intersect with B divided by probability of A. Alright. Actually, these two formulas are derived from this formula here, from the non-independent event formula to find the value of probability of A and B. Okay. From these two formula, we derive the formula of conditional probability. Okay, let's try this example number 12. The data below shows the information of undergraduate students in UiTM Samarahan. Okay, this is actually cross-tabulation or contingency table. Okay, we have the total for male and female students, and we also have the total for each major. Okay, question A, given that the student is a female, what is the probability that she is majoring in accounting? So this is actually a conditional probability. Okay, for question A, we need to find the probability that the student is majoring in accounting given that the student is a female. So this is the event that is already occurred. Alright, okay, let's say this is event B. Okay, the student is a female, is event B, and the student is majoring in accounting is event A. So now for question A, we need to find the probability of A given that B has already occurred. Okay, now how to find the value of probability of A given B? Okay, because the question already gave us the cross tabulation, so for this case now, you can use the information in cross tabulation to figure out the answer for this. Okay, you might also use the formula that we have discussed before, but I think for this question, even without using the formula, you can figure out the answer. Okay, now for question A, the event that is already occurred is this one. The student is a female. So now look at the column of female. So total we have 400 female in UiTM Samarahan. Okay. So now this event already occurred. So total of 400. Okay. Because this event, the total outcome is 400. Okay. Now we want to figure out this value. Okay. Now refer to this column. We want to figure out the student that is majoring in accounting. So now accounting is this row. So for this row, the female that is majoring in accounting is 110. So 110 out of 400 female. So the probability is 110 over 400. Okay, and we can simplify this fraction into 11 over 40. Okay, so this is the probability of probability of students majoring in accounting, given that the student is a female. Alright? Okay, senang kan? Okay, let's try the next question. What is the probability of selecting a male student? So now we want to find the probability of selecting a male student. Okay. Okay, let's say this is, I name this event as event M. Okay, probability of selecting male student. Given that, so slash, okay, given that the student is majoring in finance. So the event of majoring in finance, I name this as event F. So now, I want to figure out the probability of M given F. Okay, probability of selecting a male student given that this F has already occurred. Okay, this F is the event of student majoring in finance. Okay, so now, okay, since this event is already occurred, this is the event of student majoring in finance. Okay, so this is the finance student. Total finance student, we have 220. And now this event is already occurred. So out of 220. Okay, now we want to find the value of this probability of female student. So in finance major, for male, we only have 120. So 120 over 220. So this is the probability of selecting a male student given that the student is majoring in finance. Okay, and we can simplify this into 12 over 22. Okay, and then simplify this again, 6 over 11. So this is the final answer. This is the probability of selecting a male student given that the student is majoring in finance. Okay, so from this question, by the cross tabulation, you can just figure out the answer of the conditional probability. Actually, you can also use this formula. Okay, you can use this formula also. Okay, let's say now I want to use the formula. Okay, for question A. Okay, for question A now, I want to figure out the value of probability of A given B. Okay, by using the formula, okay, refer to this one here. The formula is probability of A intercept B divided by probability of B. Okay, so what is probability of A intercept B? A intercept B means A and B occur at the same time. So A now is the event of student is a female. So this is female. Okay. B is an event of student majoring in accounting. This is accounting. So the intersection of these two. So the intersection of these two is 110. So 110. But now we want to figure out the probability. Okay, 110 is just the number of A intersect with B. So 110 divided by the total outcome is 1000. Okay, divided by probability of B. So what is the number of B? The number of student is a female. Okay, for female student, the total female student is 400. 400 out of 1000 student. So the probability of B is 400 out of 1000 student. Okay, and then we simplify this. Okay, you can cancel this 1000 and this 1000. So you only left with 110 over 400. And then simplify, you will get 11 over 40. Okay. So the final answer, if you use the formula, is just the same as if you just look at the cross tabulation. Okay. So for this question, for conditional probability, if the question gives you the cross tabulation, you can either use the information from the table to figure out the conditional probability value, or you can use the formula. Okay. Okay, let's try the next example. Okay, an English class consists of 12 male and 18 female students. 3 of the male students and 5 of the female students are non-Bumiputras. A student is randomly selected. So question A, find the probability of selecting a non-Bumiputra student. Okay, so let's say I name this event of selecting a non-Bumiputra student as event A. So for question A, the probability of event A, probability of getting a non-Bumiputra student is, okay, number of non-Bumiputra student is 3 plus with 5. 8 over total number of student is 12 plus with 18, 30. So 8 over 30. Okay, we can simplify this into 4 over 50. So this is the probability of selecting a non-Bumi student. Okay, next. Question B. Find the probability of selecting a male student given that the student is a non-Bumi. Okay, event of selecting a male student, I name this as event M. Okay, event of student is a non-Bumi. Okay, this one is just event A, same as the one in question A. Okay, so now this is a conditional probability. We need to find the probability of M, event M, given that event A has already occurred. Okay, so now, for this question, even though this question only give a statement, not a cross tabulation, I think we can transform the statement into cross tabulation, into a contingency table. Okay, let's say this is Bumi Putra student, this is non-Bumi, okay, this is male, this is female. Okay, total. Okay, total for male we have 12, total for female we have 18. Okay, 3 of male students are non-Bumi, 3 of male are non-Bumi, 5 of female are non-Bumi Putra. Okay, so this is the information from the table. Okay, actually we can find the non-Bumi, the total of non-Bumi student here. 5 plus 3 is 8. Okay, total student is 30. Okay, this is the information given in the question. We tabulate the information into a cross tabulation. Okay, now I can figure out this value. Probability of male given that the student is non-boomi. So now the student is non-boomi. Okay, the student is non-boomi. Total is 8. So total is 8. So this is the event that already occurred. Okay, non-boomi is already occurred. The total is 8. Okay, now we want the probability of male from non-boomi. So male for non-boomi putra is only 3. So 3 over 8. So this is the probability of selecting a male student given that the student is non-boomi. Okay. Next question C. Okay, find the probability of selecting either a male or non-boomi student. So now we want to find the probability of male or. Or is union. Okay. You must remember this or, union, and intersection. Okay, so union non-boomi. So for non-boomi, I name this event as A kan. So M union A. Right. Okay, so how to find this value? This is union of two events. So for union of two events, you must use the addition rule. Okay, so for addition rule, we must identify whether the event is mutually exclusive or not. So for this case, it is very obvious this problem is a non-mutually exclusive event. So to find the probability of M union A, the formula is probability of M plus probability of A minus with probability of M intersect with A. What is probability of M? Probability of M is probability of a male student. Okay, male student, we have 12 students. Total male 12 out of 30, 12 over 30. Plus probability of A. A is, the student is non-boomi. So probability of non-boomi, total 8 out of 30 students. So 8 over 30. Actually, we already figured out probability of A from question A, 4 over 14. Sorry, 4 over 15. We change this into 4 over 15. Okay, minus probability of M intersect with A. This probability of M intersect with A here means two events M and A occur at the same time. So for this case, probability of male and probability of non-boomi student occur at the same time. So this is male, okay, and this is non-boomi. Okay, so male and non-boomi, okay, the value, the number of student is 3. So these 3 students out of total of 30 students. So 3 over 30. Okay, okay, and then you can simplify the answer. So the final value is 17 over 30. Okay, so this is the probability of male union non-boomi student. Okay, I have another one example 14 here. I think this one, I will leave this example for you to try. Okay, please try this and please share your answer in the comment section down below. Okay, and we will discuss this in our next class. Okay, thank you so much for watching.